In this session, we want to look at negative exponents and scientific notations. Negative exponents. Let's see. Negative exponents. And scientific notations. So if we recall, we know that an exponent is nothing more than an expression that has a base and a power. So an exponential expression is of the form where A is the base and M is the power, or what we call the exponent, or other times said to be the factor. Again, if I'm giving an example, if I have 2 to the 5th power, then what it tells me is that this 5 there, which is the power, tells me how many times I got to write the 2 and multiply, or how many times the 2 multiplies itself. So this is going to give me 2 times 2, 2 times 2 times 2 times 2 times 2. And if you work this out, it's going to give you 32. Okay, so this is what we call exponential expression, or exponents. Now, like I said, in this session, we just want to look at negative exponents. So we want to look at the rule that governs the negative exponents rule. If you recall, all of the rules that we've considered so far, they are either 0 power or positive power. Now, in this session, we want to look at a negative exponents, and I'm going to move on to negative exponents here. So negative exponents. As usual, let me do an illustration. Suppose we multiply 2 to the 3rd power times 2 to the negative 3rd power. Okay, let's see how this works out. So we know that if I have 2 to the 3rd power, this is basically 2 times 2 times 2. There's 3 that tells me how many times I got to multiply the 2 by itself. All right. And this 2 to the negative 3, we don't know that yet. Let's assume that we don't know that yet. Okay. But the point here is, if we are putting these 2 together, 2 to the 3rd times 2 to the negative 3, we can apply one of the rules. We can use what we call the product rule. Remember, The product rule says that if you're multiplying two exponential expressions and the base is the same, keep the base, and what do? Sum up the powers. So 3 plus -3. Now, when you do this, 3 plus -3 gives you a 0. So this is going to be 2 raised to a 0. Now, we also established the zero power rule. The zero power rule says that anything apart from zero, that you raise it up to 0 should give you 1. Anything, any expression, any number except for 0, when you raise it up to 0, it has to give you 1. And the reason is because anything raised to 0 is taking that thing and dividing by itself, and that gives you 1. That is the main reason why we are getting 1 here, but not 0 raised to 0 will give you 1. That we said is indeterminate. If you check back on the other video, you would see the explanation there. So we have the situation where now 2 to the third times 2 to the -3 turn out to be what? 1. Now, what does it mean? Now, back in basic math, we realize that anytime two items multiply and the result gives you 1, then these two items are inverses. They are opposites in terms of multiplication. So let me put it this way. By the idea of basic math, and using the property of multiplication, when two items multiply and the result is 1, then the items are inverses. Okay. Basically, we say they are multiplicative inverses. That is multiplicative inverses. All right. For instance, if you have 2 times 1/2 gives you what? 1. So that tells you that 2 and 1/2 are multiplicative what? Inverses. So So 2 and 1/2 are multiplicative inverses. The reason is because their product gives you 1. And 1 is the identity element for multiplication. So in that same lines, we see, if we recall, that in our example, 2 to the third times 2 to the negative 3 is giving me 1. So that tells me that this means that 2 to the third is the multiplicative inverse of 2 to the negative 3 and vice versa. Okay. So if that is the case, then I can rewrite 2 to the third times 2 to the negative 3 equal 1. I can rewrite this simply as 2 to the third equal 1 over 2 to the negative 3. Remember that when two items are multiplied and you want one of them to stay, then the other one has to divide. Okay, so, well, if I decide to divide both sides by 2 to the negative 3, then I will have 2 to the positive 3 left on the left-hand side, and then the right-hand side is going to be divided by what? 2 to the negative 3. So this is always true. This is true. I can equally divide both sides by 2 to the power 3, right? Okay. So let's say from here, let me put it this way. Divide by 2 to the negative 3, right? And then you get this. I'm going to write the same thing here. Alternatively, if we divide by 2 to the positive 3, then we have 2 to the negative 3 will be equal to 1 over 2 to the positive 3. This is also true always. This is also true. Okay, so take note. 2 to the negative 3 is always 1 over what? 2 to the positive 3. So there's something going on here. A negative 3 power now becomes a positive 3 power. And what are we seeing here? There is an exchange. There's an exchange. The position is changed. Okay, so look at this carefully. 2 to the negative 3. In other words, we can divide this by 1. Okay, if you divide 2 to the negative 3 by 1, is the same as 2 to the negative 3. But look at what happens on the right-hand side. A negative power 3 now turns to what? A positive power 3. And the reason is because the position of the numbers are changed, or the position of this exponential expression is changed here. It's changed. It changed from the numerator to the denominator. So anytime a negative exponent changes its position from a numerator to a denominator, or from a denominator to a numerator, it changes from the negative exponent to a positive exponent. Okay, that is what the negative exponent idea is all about. So for instance, if I have 2 to the negative 1, this is the same as 1 over 2 to the positive 1. And this is the same as 1 1/2. If I have 3 to the negative 2, this is the same as I write 1 over 3 to the positive 2, which is the same as 1 over 9. So look at it carefully. If you have 4 to the negative 2, this is the same as 1 over 4 to the positive 2, and this gives me 1 over 16. This is true all the time. True all the time. This is what a negative exponent is all about. So negative exponent is always expressed as a positive exponent by changing the position of the exponential expression. Okay, so let me put it this way. Note, a negative exponent becomes a positive exponent as a result of changing the position of the exponential expression. When I talk about position, I'm talking about the denominator and the numerator. So if it was negative exponent in the numerator, it comes to the denominator and it becomes what? A positive exponent, and vice versa. If it is in the denominator, it goes to the numerator, it becomes what? A positive exponent. So let's put it in general. General, if let's say n is an integer, if n is an integer and let's say x is not equal to 0, then this negative exponent, x raised to the negative n, is defined as and this is basically what I have explained. So that is key. Anytime you're dealing with negative exponent, that should come to mind. That should come to mind. It's very, very easy. X raised to the negative n is always going to be equal to what? 1 over x to the positive n. In other words, the negative exponent has now become a positive exponent as a result of what? Changing the position of what? The original what? Exponential expression. All right. Let's do some more examples. Go to the next page. Example. Simplify the following completely. b raised to the negative 16 3 raised to the negative 3 let's do 2 raised to negative 1 plus 3 raised to negative 1. Let's look at the solution. Question 1, b raised to the negative 16. Remember that it is negative exponents. We got to change it to a positive exponent. And that means that this is going to become 1 over b to 16. That's it. If you follow the rule, it's very, very simple. We have 3 raised to negative 3. The same preamble. It is negative exponent. We need to change it to a positive exponent. So that means that the position of this exponential expression is going to change. It goes to the denominator. And it becomes what? A positive. Here we have numbers, so we should be able to evaluate. 1 is 1. 3 raised to 3 is 3 times 3 times 3. And that will give me 1 over 27. Please take a moment to verify yourself. And then the third one, we have 2 to the negative 1 plus 3 to the negative 1. Remember, we have 2 items here we want to add. And these 2 items are exponential, and they are all negative exponents. So look at it carefully. 2 to the negative 1 in terms of changing to a positive exponent will be 1 over 2. This one is going to be 1 over 2 positive 1. This one will also give you 1 over what? 3 positive 1. So look at it carefully. I'm just using the rule. And this is still going to give me 2. Any number to a power 1 is the same thing. So that will give me that. Now we have a fraction. Remember what fractions are. When you're working fractions, you need to determine what the LCD is. The LCD of 2 and 3 is 6. LCD of 2 and 3 is 6. Okay, so we need to change the 2 and the 3 to 6. How many times are we going, or what are we going to multiply by 2 to get me 6? What are we going to multiply by 3 to get me 6? And remember that it's a fraction. What you do to the numerator, you do to the denominator. So this is going to be 1 times 3, 2 times 3, plus 1 times 2 over 3 times 2. I believe we already know how to do this. That gives me 3 over 6. That gives me 2 over 6. And once we have the same denominator, we keep that, and then we sum the numerators. This will give you what? 5 over 6. So remember that this implies that if you have 2 to the negative 1 plus 3 to the negative 1, your result is 5 over 6. It's very, very simple. Very, very simple to do this. Now let's look at what we call the quotient of power. It's still under the negative exponents though. So quotient of negative power. Rule. Okay. So we all remember the power rule. Power rule is very, very simple. Power rule talks about the fact that if you are in the, like I explained, if you are in a room full of individuals in the room, the power that serves as the roof, whatever the roof is going to do, you guys are going to have an impact. Every item that is going to have an impact. So in this particular case, if I have something like this, x over y all raised to negative n. Okay, where x and y are some items, and the n there is an integer. This time it's a negative integer. Now remember that by the power rule, we can rewrite this as x raised to negative n, y raised to negative n. Okay, so this is me. We are in the same room, but I'm sitting in front and you are sitting at the back. The negative n there is the roof. No matter what the roof, if the roof is leaking heavily, we are going to be wet at the same time. So what it is that every individual, every item there takes what? The power. And this power there is what? Negative n. Okay. Now, we understood from the beginning that anytime you have a negative exponent, you need to change it to a positive exponent. And what it does is that it changes its position to become positive. Okay, so if I'm going to change x raised to negative n to a positive n, then I need to change the position from numerator to denominator. And then if I need to change that from negative exponent to positive, it has to change or move from the denominator to the numerator. So this is the same as a right. This is always true. Always true. Here, note that both x and y should not be 0. Okay. For instance, if you have 2 over 3 all raised to negative 2, this is the same as a right. 2 to the negative 2, 3 to the negative 2, and then I swap them up. Just swap them, and then they become what? Positive. So that goes to the top, and that comes down. They become positive. And then 3 to the second power is 3 times 3. And 2 to the second power is 2 times 2. And as you go through it, that should give you 9/4. 9/4. So it's a very simple concept here. Okay, a very simple concept that if we have items in a room, so to speak, and the exponent is negative, all that you gotta do here will be to swap the positions to make it what? Positive. Okay, to make it positive. It's very, very simple. Let's do another example here. Simplify this. If I gave you 1/4 raised to -3, it's very simple. One over 4 raised to -3. This is the same as I write 1 to -3, 4 to -3. Now what I'm going to do here is I'm going to swap the positions of these two items. And then once I swap their positions, the negative exponents will change to positive exponents. So look at it carefully. And 4 to the third is 4 times 4 times 4. 1 to the third is 1 times 1 times 1. Okay. And remember that anytime you divide something by 1, it's the same thing. So this is just going to give you 64. Be the answer. So what is happening here? This is a very simple situation. Look at it carefully. You can even do it from here. Alternatively, I have 1/4 raised to the -3. Okay, what I can do is I can just swap the 1 and the 4, and then this is just going to change to positive. So this is the same as I write 4/1, and then the power changes to positive. Once I swap the numerator and the denominator, the outside power becomes what? Positive. And 4 divided by 1 is 4. And I raise up to 3, it gives me what? 64. So whichever way you want to do it, you're still going to get right. This is what negative exponent is all about. So let's do a couple of examples that you will find in your homework assignment. Let's look at general examples. If you are able to understand these examples, you should be able to work on your homework assignment easily. Let's look at this question 1. It says simplify completely. Without negative exponents. So we have 8y -9, and then 3y positive 7. Let's look at it. Solution 8y to the negative 9, 3y to the 7. Now what I'm going to do is that I'm going to put the coefficients together. If you look at a previous video, that is what we're doing. In a case like that, multiply the coefficients, the numbers in front of the variable. So it's just going to be 8 times 3. And then you also combine the exponentials. So y to the negative 9 times y to the 7. And 8 by 3 is 24. Right? Times. Here we use the product rule. The product rule. We use the product rule. Use product rule. Product rule says that if they have the same base and you are multiplying, keep the base the same and sum up what? Their powers. When you do that, this is 24 times y. Negative 9 plus 2 is, sorry, negative 9 plus 7 is negative 2. Now, we don't need any negative exponents. And so this is where we have to use the negative exponent rule. We want to change this from negative 2 to positive 2. And that means that by using the rule, this is going to be 24 times 1 over y squared. If you go back to the notes and the rule, you will see. And I can divide this 24 by 1. So basically, when I multiply numerators, it's 24. And I multiply denominators, it gives me y squared. And I'm all set. You should be able to do this easily. Look at it carefully. Coefficient first. Multiply the coefficients, the numbers in front of the variable. And then now also multiply the exponentials because they have the same base. You just use your product rule to combine them. And then if you are getting a negative exponents, you have to use the negative exponent rule to change it back to what? A positive exponent. And that means that it's going to change its position. All right, I hope this works out. Let's go to another page and do some more examples. So this is 2. What about this one? Simplify. Three x to the 7 all raised to 4 divided by x to the negative 2. So 3 x 7 to 4 all over x to negative 2. Now, here we are going to apply some of the rules that we already know. In the numerator, we see that we have 2 items there. We have 3, and then we have what? X to the 7th power. And then they are all what? Raised to 4. So this is a situation where you have 2 items in the room being covered by a roof or a ceiling, if you will, and the roof or the ceiling has an impact, and it's going to what? Impact both of them, or it's going to affect them. So 3 has to raise to 4, and x7 also has to do the same. Then that is this. 3 raised to 4 is 3 times 3 times 3 times 3, and that gives you 81. Now you can do this. Now here, we also use what? A rule, a power rule. 2 powers will always multiply. 2 powers will always multiply. So this is going to give me x 28. Because the 7 multiplies what? 4, and that is 28. Divided by x, again, negative 2. Now think of it. We don't want negative exponents. So I need to get this out from here. I need to move this. To change this from a negative exponent to a positive exponent, it has to what? Move positions. It has to move from the denominator to the numerator. So this is how it's going to be 81 x 28 times x positive 2. And because it's moving, it leaves 1 behind. But again, anytime you divide anything by 1, is the same thing. So this is still going to be what? 81 x 28 times x 2. Now, if you look at this carefully, these two here, we can use the product rule. Product rule. You can use the product rule there to find your result or combine them. So 81 is going to stay. The product rule says that if you have 2 exponential expressions, you're multiplying the bases the same, keep base the same, sum up the powers. So 28 plus 2, and when you simplify, you're going to get 81x raised to 30, and that will be your final answer. Let's do some more, do some other ones. So let's say this is 3, simplify. This is a to the negative 3. A to the negative 3 times b to the positive 5 all raised to negative 3. To simplify this, that should be equally very easy. A to the negative 3 times b to the positive 5 all raised to negative 3. Remember that this is one item, this is another item. We have 2 items in a room, all under the same roof. If the roof is coming down, the impact is going to be the same. So what it means is that a to the negative 3 has to raise up to negative 3. And then b to the 5 has to also raise up to what? Negative 3. Remember, this negative 3 there is not because the a there has negative 3. No, I'm talking about the outside power, which is negative 3. This outside power has a weight on each one of these items. So a to the negative 3 has to raise up to negative 3. And then the b to 5 will also do the same. So take note of it. Now, from here, we know of a rule that if there's an inner power, it multiplies the outside power. So this is going to be a negative 3 times negative 3. Same will be for the b. b 5 times negative 3, because we have an inner power and an outside power. They multiply together. That's one of the rules that we studied. So this is going to be A. Negative 3 times negative 3 is positive 9. And then B, 5 times negative 3 gives you negative 15. But you're not done yet. Remember that we do not want negative exponents. When you have a negative exponent, you got to change it to what? A positive exponent. And that means that you're going to change the position of that particular exponential expression. Now, in this particular case, we have b to the negative 15. For me to change it to b to a positive 15, it will have to move from the numerator to the denominator. So it becomes a to the 9 times 1 over b to the positive 15. Right? And from there, I can just multiply. I can divide this by 1. It's the same thing. So I'm multiplying numerators and denominators. I'm going to have a to the 9 divided by b to the 15. And I'm all set. Let's do some more. Three. So let's say 4. Just simplify. And then write your answer without negative exponents. And then it says, assume that no denominator equals 0. Okay. So read it carefully. And this is the expression. M to negative 3 W to 4 and the Y divided by M to positive 4 W to negative 2 and Y to positive 5. So here we go. How do we simplify this? Solution. So M to negative 3 4 Y divided by M to 4 W negative 2 Y to 5. So look at it carefully. We do have some negative exponents there. We have M to the negative 3. We have W to the negative 3. Now, I need to first change these guys to positive exponents. And what that means is that I need to interchange their positions or move their positions. So M to the negative 3, if I'm turning it to a positive 3, it has to move down. And then the W to the negative 2, if I'm changing it to a positive 2, it has to move from the down or the denominator to what? Numerator. So if I do that, this is what I have. Look at it carefully. Look at it carefully. So you see on the right side, you don't see any negative exponents anymore Why is because I've changed the negative exponents to positive exponent by what? Changing their positions. Okay. So from here, a couple of things that we can combine. If you look at the W's, these items are all multiplying. These are all multiplying. So if I look at the W's, I can use the product rule. They have the same base, W, and I can sum up what? The powers. So it's going to be W 2 plus 4 and times Y. Just doing this step by step so you get the understanding. If I look at the M's, it's the same preamble. I will keep the M and sum up what? The powers. And once I do that, I have W6, Y, and M7, Y to the 5th power. But wait, I'm not done yet. Because I see a letter in the numerator, which is the same letter I see in the denominator. So here I need to also what? Completely simplify this. And because this is rational, it's like a fraction. We have a numerator and denominator. It means that this serves as what we call a quotient. So we're going to use the quotient rule here. So let me put it this way. Use quotient rule for, but that's to simplify the Y. Okay. And so the Y to the 6 is going to stay. The M to the 7 is going to stay. But remember what quotient rule says. Quotient rule says that if you have two items dividing, they have the same base, subtract the smallest power from the largest power. In this particular case, this is Y. It has a power 1. Normally, we don't write it. So the power 1 is here. And this Y has a power what? 5. So for me to simplify, this Y has to subtract from this Y to the 5th power. Okay. And that means that it is moving its position from the numerator to the denominator to subtract. So you will have a case like Y 5 minus 1. And at the end of the day, you would simplify your result. Y6, M7, and Y4. So W6, M7, and Y4 will be your answer. So you should be able to do this easily, very easily. Let's do some more example. 5. What about if you have to simplify -3 times W5 all over W3 times D squared all raised to -2. Simplify, right? So look at it carefully. Outside power is what? Negative exponent. The outside power is negative exponent. Now, anytime the outside power is negative exponent, you need to change it to a positive exponent. What you got to do here is you want to swap the numerator and the denominator. So this is going to give you something like this. I'm going to swap the numerator and the denominator. So the denominator is going to go to the top. The numerator is going to come down. And the outside power now changes from negative to positive. So this is one of the rules of negative exponents. Remember when we're talking about the rational negative exponent rule? That is what it is. So if you have a fraction in parentheses and the outside power is negative, to change the negative exponent to a positive, just swap what is inside and that'll be it. So from here, we can now apply the rule that every item that I have in this parenthesis has to raise up to what? Positive 2. So this is going to give me W cubed or squared, D squared or squared, negative 3 or squared, Y to the 5th power or squared. This, remember, power rule. 2 powers will multiply. So this will give me W6, 2 by 3 is 6, 2 by 2 is going to be 4, so D4. Here, negative 3 times negative 3, that's what it means. Okay, negative 3 raised to what? 2 is negative 3 times negative 3, and this is going to give you 9. Then here, by the rule, 5 multiplies 2, and you're going to get 10. You are not done yet. You can cross out stuff here. In the numerator, you have what? W to the 6. In the denominator, you have what? W to the 10. We can use the quotient rule there to, cross out some of the W's. So this is just going to give me D4 over 9 and W4. And the reason is because 6 has the smallest power. You look at the W's, 6 has the smallest power. So it comes down to subtract from what? 10. 10 minus 6 is going to be 4. And that will give you your answer. So this is not too bad. Too bad. Just look at it carefully. Go to the next page. Let me do the last question. What this number is 6. So simplify again. P to the 3rd over W to the 5th, all raised to negative 1. That should also be very easy to deal with. P 3rd, W 5th, all raised to negative 1. Remember, because the outside power is negative, I need to change the outside power to positive. And what I do is I swap these two here. So this is going to give me what? W5 over P3. And then that changes to positive 1. And remember that anytime whatever inside is affected by the power. So this is the same as I write that and then 2 powers multiply. 5 times 1 is 5. 3 times 1 is 3, so p to the third, and you are all set. I hope this helps you out in your assignment. Let's look at scientific notations. Scientific notation. So just as the name implies, there are certain numbers that are better used in sciences, and most especially when you're talking about maybe physics, you're talking about chemistry. There are some large values or very, very, very small values that we cannot continue to write them. And so there's a need for us to express them into what we call scientific notations. For those of you who have done a little bit of chemistry back in the days, that's what we call the Avogadro's number. Avogadro's number, I think, is about 6.022 times 10 raised to the 23. It's a very, very, very large number. Some of these numbers we cannot, often write them. Otherwise, we would need a lot of notebooks. They are equally minute, very, very, very small values that we cannot keep writing them. And so the best way will be to rewrite them into what we call scientific notation. So I'm just going to go ahead and introduce scientific notations to you. A number in scientific notation is of this form. A number in scientific notation is of the form so note how so the form, let's say a times 10 raised to n. Something like that, where the a there, to put it in an absolute form, it should be strictly less than 10 and should not be lower than 1. Okay, so we have a very large number that we want to write, but we cannot continue to write it. And so we need to express it in this form. And this form is what we call the scientific notation. This a value here has to lie within this condition. It has to lie in between 1 and 10. It could be 1, it could be 2.5, it could be 9.1. It shouldn't be 10 or more, and it should not be less than 1. Okay. So please take note of that carefully. Here, the n there is an integer that tells the number of times the decimal point of a number, a given number, is moved either to the right or to the left. Okay, so that is what the N there stands for. Now, if N is positive, then decimal point is moved left, and N is negative, when the decimal point is moved to the right. Okay, so the number of times that we move to the left or to the right determines what N is. If the number of times that we move the decimal point to the left is 10, it means that N is going to be positive 10. The number of times that we move to the right side, the decimal point to the right side is 5. It means N is going to be negative 5, and vice versa. So that shouldn't be too hard. Okay. An example would be to write in scientific notation. Write in scientific notation. The number there is 82,760,00. So 82,760,000. Okay. So note that every number in this world has some decimal place somewhere. If the number is a whole number, the decimal point is always at the end of the last digit. Remember that we are reading the number from left to right. So that is why this is 82,760,000. So we are moving from what? The left to right. So if the number is a whole number, not a decimal, then basically you expect the decimal point to be after the last digit of the whole number. So in this particular case, the decimal point is right here. Let me just write. Decimal point is right here. Okay. Now, because this number is a very huge number, the only way out to satisfy the condition where we express it such that the number is not going to be in between 1 and 10 will be to move it to the left. So I'm going to move this point 1, 2, 3, 4, 5, 6, 7. So it's going to be in between the 8 and the 2. So that means that I'm going to have 8.2760000, and then times 10 raised to how many times I moved? 1, 2, 3, 4, 5, 6, 7. Because I moved to the left, I put 7 on top of the 10. But These zeros there are just placeholders. So I can rewrite this as 8.276 times 10 raised to 7. And I'm done. Take note of it. If I have 25.72, it's the same idea. This is 25. It is bigger than the condition where it has to lie. It has to lie in between what, 1 and 10. And because this is already 25, it is outside the condition. So that means that for me to satisfy the condition, I will need to move this decimal point here back one time. It has to move here, you know. And so this will just give me 2.572 times 10 to 1, because I moved only one time. Let's do another one. What about 0.12345.178? Let's carefully. This is a very, very small number. Very, very small number. That is less than 1. Remember that the condition of the number at the end of the day is that it has to lie in between 1 and 10. 1 and 10. Anything outside 1 or anything more than 10 violates the condition. And because this is small, for this to satisfy the condition, I need to move it to the right. Okay, so I'm going to start from the decimal point, move 1, 2, 3, 4, 5, 6. And I stop here. So that it will give me 1.78 times 10 to the negative 6. 1, 2, 3, 4, 5, 6. Remember, if you move to the right, the number of times that you move becomes a negative exponent. And if you move to the left, the number of times that you move becomes a positive of the number of times that you move. What about 0.367? This is equally violating the rule. The number has to lie in between 1 and 10. This is 0.367. This is less than 1. So it is outside the rule. For this to be in the rule, I need to move it to the right. Okay, I have to move it to the right only one time so that it becomes 3.67. 3.67. And once I do that, it times 10 to the negative 1 because I moved just one time. All right, so this is what scientific notation is all about. But now that we know how to use the exponent rules, there are cases where we need to evaluate some of these scientific notations by way of employing the rules of the exponents. So let's do some of these examples. Evaluate. The following and leave your answer in scientific notation. scientific notation. So I have A here, I have 2, 3, 0, 0, 0, 0 times 4, 5, 0, 0, 0, 0, 0, 0, B 7.2 times 10 to 5. And I have 3.1 times 10 to -4. So let's look at these two examples. And the first one is 2, 3, 0, 0, 0, 0 times 4, 5, 1, 2, 3, 1, 2, 3. So the question says that evaluate the following and leave your answer in scientific notations. Because we are to leave our answers in scientific notation, what it means is that it will be better if we first change every number there in their normal form, the standard form, to the scientific notation, so that we can easily evaluate and leave our answer there. So this is a very huge value. This is 230,000. The decimal point is right here. So I'm just going to move 1, 2, 3, 4, 5. So that will give me 2.3 times 10 raised to positive 5. Same here, the decimal point is right here. So I move 1, 2, 3, 4, 5, 6, 7. So that will give me 4.5 times 10 to positive 7. Because I move to the left, it's always positive exponent. And then here, I'm going to multiply those without the powers. So I'm looking at 2.3 times 4.5. And I also combine those powers, 10 to the 5th power times 10 to the 7th power. So just grab your calculator and find 2.3 by 4.5. 2.3 times 4.5 gives me 10.35 times. Here we have to use the product rule of exponents. Says that if you have two exponential expressions with same base and there's a multiplication, you hold the base and then you sum up the powers. So there'll be 5 plus what, 7, and that will give you 10. 10.35 times 10 raised to 12. Now, this is not right. It is not correct because this number here is more than 10. And that violates our rule. So what I'm going to do is that I have to make sure that this number becomes a number that lies in between 1 and 10, the only thing I can do will be to move the decimal point back one time. Okay, so if I do that, I'm going to have 1.035. So I'll move this one time back. The decimal point now moves from where it is now between the 0 and the 3, and then now it counts between what, the 1 and the 0. So that makes it 1.035 times 10 raised to 12 plus 1. And it is plus 1 because I moved this back one time to the left. So anytime you move to the left, it's positive. And because I move it one time, I need to add a 1 to the power here. So that becomes 1.035 times 10 to the 13. And I'm all set. Look at it carefully. It's not too hard. Should be able to do this easily. The second one, $7.2 times 10 to the 5th power times 3.1 times 10 to the -4. So it's the same preamble. These are already in exponential form. So I'm just going to combine those without the exponent, which will be 7.2 times 3.1. And then I also combine the 10s with a power. Again, I'm going to multiply 7.2 by 3.1, and that gives me 22.32 times 10. Remember that I'm using the product rule. I keep the 10 the same, and then I sum up the powers. So 5 plus -4 will give me 1. Again, this is 22.32. It is bigger than 10. Remember, the condition is that the number here should lie in between 1 and 10. Because it's bigger than 10, what I got to do here will be to move the decimal point back one time. And because I move back, the number of times that I move back is positive. I add it to whatever the power here is. So if I'm moving it one time, it becomes 2.232 times 10 to the power 2. Because I move it one time back and I add a 1 to 1, becomes 2, and I'm all set. So this is quite easily done. I'm just going to go to another page and do some more examples. So this is C of 3. What if we have evaluate and write answers in scientific notation? So I have 0.0072 divided by 0.0035. 0.00036. So let's look at it carefully here. 0.0072 and 0.000036. I'm going to change these into scientific notation. These are very small numbers. They are less than 1. So I need to move them to the right. I move the decimal point to the right. In the numerator, when I move it to the right, it's going to be 1, 2, 3. So that will give me 7.2 times 10 to the negative 3. In the denominator, the same. I move 1, 2, 3, 4, 5. That will be 3.6 times 10 to the negative 5. So here is where you have to be very careful. I'm going to combine these numbers as usual. So I'm going to do it this way. So look at it carefully. Combine my times here. And I also combine these ones here. Now 7.2 divided by 3.6 basically gives you 2. So this is 2 times. Now remember, here you have to apply. So use red just so that you know. Use negative exponents. Negative exponents. Remember, negative exponents, you need to change it to a positive. And once you do that, you swap the positions. So this is the same as I do 10 to the 5th power over 10 to the 3rd power. Because I'm changing the negative exponents, I need to move their positions to do that. Okay. So that at the end of the day, I get my 2 times here. You're going to use the quotient rule. Use the quotient rule. The quotient rule says that you subtract the smallest power from the largest power. So this is going to be 10. 5 minus 2. 5 minus 3. Sorry about that. 5 minus 3. And this will give me 2 times 10 to the power 2. And because this 2 lies in between 1 and 10, it means that I am all set. I hope this helps you out, even as you work on your homework assignment. Thanks for watching.